instead of having to have a for loop and a length and an iterator, there's a new way to go through loops. And this is the syntax right here. So for, still a for loop, but it just says the type of your element and the name of your array. So it'll go through the array one at a time and stick each element into a variable for you that you can then use. So some nice things about it, you don't have to worry about getting the values of I correct. You don't need to worry about going out of bounds or accessing individual elements. And it puts it in a variable for you. So it just removes the potential for errors. In the background, Java still does the same thing. It actually just fills in the code for you. But this is really nice because it's basically a shortcut for this kind of for loop. You don't have to do this anymore. You still need to know how to do it because it'll be, obviously you'll be tested on it, but there's an easier way to do it using what's called a for each loop. So instead of this, right, we can now say this. So these two loops are syntactically different, but underneath the covers, they do exactly the same thing. This second one is much less error prone because it does a lot of the work for you. It goes through this one at a time from beginning to end and stores each value in this variable, and you can use that variable in your loop. So it goes through storing 0 in this score, then 10 in this score, then 20 in this score, then 30. So you don't even have to worry about where you are in the loop or if you're going to go off the end or anything like that. It just does all that work for you. It's pretty nice. Oops. So here's a couple examples. One key that you do have to take note of is the type of that variable, that temporary variable that's walking you through it, does have to be the same as the type of the array. So for high scores, it was an integer array, so the value has to be an integer. That's what I just showed you in the REPL. For the names array, that's an array of strings, so the variable name has to be a string, and it'll just print out all the names in that array. So these are some caveats. The enhanced for each loop is really, really useful for 95% of the time because you do the same thing with for loops or arrays. You're going through all of the elements, but there are situations where you don't, right? Like if, for example, you're using parallel arrays, right? Remember where you have related data in multiple arrays. If you have all position 4 of first name, last name, blah, 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 are in different arrays, but they're all at position 4 for the same person, you have to know you're at position 4. In a enhanced for loop here, you don't know what position you're at. There is no index here. It just goes through them one at a time, and all of that detail is kept in the background. So you don't want to use them if you need to index for some reason. You can't change the value in the array, right? If you look here, right, if I change this score, it's not actually going to change what's in high scores. This score is a local variable. It doesn't actually link to the data inside high scores. What's happening is it's copying the data out of high scores into this score one value at a time. So even though I set this score to 1, 2, 3, 4, you can see when I print out the values of high scores again, they're still 0, 10, 20, 30, 40, 50. So if for, you're going through an array and you need to multiply all the elements of an array by 2, you can't use an enhanced for loop. This score times equals 2 will have no effect on the actual array. You'd have to do it, this way. And then it would work. Oops. Yeah, and then if you want to go back to front, or you want to skip by 2s, or you only need the first 3 elements, right, you wouldn't use an enhanced for loop. So again, a lot of the time, for each loops are great. They do one specific thing really well, but there are some places where you don't want to use them. So let me do this quick. I'm going to actually give you, I'm going to make a new array here. So give me a second. I'm going to have you guys fork this again. And so I just want you to write an enhanced for each loop that prints out all the names. So that's going to be our quick check for understanding. So fork that and add a for each loop. All right, anybody care to copy and paste their for each loop into the chat. All right, I'm going to copy and paste Zoe's into my REPL and see what happens. It works. All right, so one more challenge for you before I let you go. All right. So you can copy and paste this into your code. Because I'm a super programmer, Peter, and computers are scared of me. So what I want you to do, you can just refork this if you want, enhanced for each loop. Print out the minimum, maximum, and average values of nums. So I'll give you a hint. You're going to have to start with maximum equals negative blah, 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 blah. I don't know if we can do that. 9, 0. Minimum you might need these. See if you can figure out how to print the minimum, maximum, and average value of this or double array nums. I'll give you, what time does this class end? $11:23, is that right? Okay. So I'll give you 5 minutes. You're going to need a few of your skills from the previous chapters to successfully do this. All right, anybody have any questions before I talk about how to do this? Anyone care to copy and paste their solution into the chat or share their screen? These look like reasonable solutions. Anyone else? Okay, so I'm going to go through it quick, and then I will let you go. So we have our numbers here, an array of doubles, initialized to all this stuff. And the reason that I set maximum to this really low negative number and minimum to a really high positive number is because I know that all of the numbers are bigger than that max and smaller than that min. So the first time I check to see if a number is bigger than my current max, it's going to set it to the max. So what I want to do is basically go through all these numbers and have some way of saying if the current number is bigger than what I've stored as the maximum so far, then the maximum should be set to the current number. And the opposite for the minimum, right? I want to go through and say, if the number that I'm looking at is less than whatever the minimum was previously, well, then this must be the new minimum. The problem with that is the first number. If I set these to 0, then it might stay at 0. Right? There might not be any numbers below 0 in my list. So I might not actually get the minimum. Whereas if I set the minimum to this super trillion blah, blah, blah 999 thing, I know that, you know, there will be numbers in my list that are less than that. So I'll find the real minimum. It won't stay, the minimum won't stay here because all the numbers in my list are not bigger than this minimum. All right, so anyway, let's get to it. So for this num, oops, sorry, double this num in nums. And there's nothing special about the word this in this case. I just like that because it reminds me that it's going through it one at a time. That's just my convention. I don't know if anybody else uses it, but I like it. So if this num is greater than the maximum that I have stored before, then max must be equal to this num. So all I'm saying is max is keeping track of my maximum number so far. So as I go through the list, if I find one that's bigger than the max so far, then I reset max to this one. This is now the biggest number. And it'll just store it in there until I get to the end of the list. And wherever my biggest number was, it will be stored in this variable called max. Same thing for the minimum. If this num is less than the minimum number that I've stored, then store this number in minimum. So after the first iteration through this loop, both max and min will be set to 1. Because 1 is greater than negative 9999. It's the biggest number we've seen so far. 1 is also less than 9999999, so it's also the smallest number we've seen so far. So that's why I did it this way. It automatically works on the first number, and then as we go on, it will update based on whether it's bigger or whether it is smaller. But I also have to keep track of the sum and the count. So the sum is pretty easy. Every number, I just say sum becomes equal to sum plus this number. I can write it that way, or I can write it this way if this is more clear to you. And I can add 1 to the count as well. So at the end, I need to print out the minimum, the maximum, and the average. So I don't have an average variable. I could create one, or I can just say system.out.println min plus min max plus max, whoops, plus max plus average plus sum divided by count. All right, so let's try that. So the minimum was -8, the maximum was 500, the average is 83.28. Minimum, -8, that looks good. Maximum 500, 500. Yep. And the average, all right, so what if I add in a new one? Negative something huge. There we go. -2 to the power 11, so that was probably too big. Let's do that. Still doing it. There we go. 238,362. Yay! It works.